Good morning. This is your stats sensei, Mr. Spensei, and this is scenario 2 of the take-home quiz. This was a 2009 B question 5. So a bottle filling machine is set to dispense 12.1 ounces in juice bottles. So this right here is telling this is what it's set to do. So this is the claim that's at 12.1. That's our population mean. To ensure that the machine is filling accurately every hour, a worker randomly selects 4 bottles. So we have a sample size of 4 filled by the machine during the past hour and measure the contents. If there is convincing evidence that the standard deviation is greater than 0.05, the machine is shut down. So if our population standard deviation is greater than 0.05, if greater than 0.05, we shut the machine down. That's interesting. And what's interesting is we bring this up now, but we don't address this in part A. We're going to address this later, but that's important information. I wish they'd put it closer in part B, but here it is in part A, and we are going to have to refer back to this. The machine is shut down for recalibration. It can be assumed that the amount of juice that is dispensed in the bottles is normally distributed. So we have a sample size of 4, a population mean of 12.1. It's normally distributed, and we said it's a random sample. All right. During 1 hour, the mean number of fluid ounces of 4 randomly selected bottles was 12.5. Oh, this is what came from the sample. So our X bar is 12.05. And we had a sample standard deviation of 0.058. So this is our standard deviation of our sample of 0.085 as opposed to that 0.05 maximum. Perform a test of significance to determine whether the mean amount of juice dispensed is different than from 12.1. Different means not equal to. All right. Assume the conditions for inferences are met. Now, this is really important. In our previous question, they didn't have this, so I didn't. I needed to list the conditions here. I don't need to list the conditions. I'm going to. Don't do this normally. If they say this, don't do it. If you write it and it's wrong, you lose points. But because this is here, you didn't have to do it. But I'm going to list those conditions just to show you how they were met. So the claim. They claim it's 12.1. We're going to believe it. Then they wanted to know the key word that they used to said was different. So different is not equal to 12.1. So let mu equal the true population mean number of fluid of ounces of juice, technically in the bottle. All right. Or bottles. We have a random sample of 4 that was given. And by the way, this was not required because they told us if inferences had been met, the conditions had been met. If they hadn't said that, we definitely would have had to do this. So I'm going to show you it's a random sample of 4. So yay, it's random. That's good. 4 times 10 is 40. And I'm reasonable to assume that there are at least 40 containers of juice. And the distribution of juice is normal, and that was given. So we have to have the normality condition. Remember, we can show normality because they told us it was normal, which is what they did. If n is greater than or equal to 30, then if our sample size is 30 or greater, then it's normal by central limit theorem. Or if they have data listed, we'd have to graph the data and check to see that the box plot was reasonably symmetric with no outliers. Well, we had a X bar of 12.05. We had an S of 0.085. We had an N of 4. Because we're working with the standard deviation of a sample, we have the standard deviation of a sample, we have to use a t distribution. So the probability of X bar does not equal 28 is 2 times the probability. Very important that you have this. And by the way, t equals X bar minus mu S divided by square root of n. Once we write it down, we cross it out. 12.05 minus, this is the claim, 12.1. Our sample standard deviation, our sample size is 4. So once again, we're going to go do a stat test, t-test. But in this case, our mean is 12.1. Our sample average or sample mean is 12.05. Our sample standard deviation is 0.085. And our sample size is 4. And not equal to, calculate, and we get 2 times the probability that t is less than negative 1.1764, because this is what we ended up with. We had a mean, and I should have drawn this already, of 12.01, and we had a x bar of 12.05, and we're looking for that probability right there, okay, that shaded area. So when I did that, I ended up getting a pretty large p-value of 0.3242. Well, 0.3242 is greater than alpha. We're going to fail to reject. Our p-value is 0.3242. We fail to reject the null. There is not sufficient evidence that alpha equal 0.05 to suggest the true population mean number of ounces of juice is different than 12.1. Great. All right. The way they scored this part is they gave you basically this problem was worth 3 points. That was 0.1. 0.2 was the calculations. And 0.3 was our conclusion. All right. And then we have part B, and that would get our fourth point. So let's look at part B. First off, we got all this information up here that we haven't read yet. To determine whether this sample of 4 bottles provides convincing evidence the standard deviation of juice is greater than 0.05. Oh, we want to know the probability that the standard deviation is greater than 0.05. Well, that means, and they told us up above, the standard deviation is 0.05. It's normally distributed. And that's the population standard deviation. But we got a sample standard deviation of 0.085. And that's where I thought things were confusing, is you had to come back and look back up here. So this is S, and this is 0.085. So that's what's going on. So a simulation study was performed. In the simulation, 300 samples of each of size 4, so N is 4, were randomly generated from a normal population with a mean of 12.1. And they're telling us the standard deviation of that population is 0.05. So they basically created what I just drew. The sample standard deviation was computed for each of the 300 samples. The dot plot was displays the values of the sample standard deviation. All right. Use the results of the simulation study to explain why you think the sample provides or does not provide that the standard deviation of juice dispensed exceeds 0.05. All right. So I look at this thing, and this is my distribution. But what did we get from our sample? We got 0.085. And they're saying it should be at 0.05. Well, this is their simulation of 0.05. When we see we have some below, we see some above. All right. Well, here's 0.085. So we're looking for this shaded area. So we're looking for the part greater than 0.085. And I should be drawing this on my graph. And I circle that and I go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of, how many were there? So 12 samples out of 300 had that type of variation. So 12 samples out of 300, 12 samples of 4 bottles had a variation of 0.085 or greater. All right. So probability of getting a value of 0.085, 0.085 or larger is 12 or 300, which is 0.04. Well, that's a pretty small p-value. It happens to be less than 0.05. So our p-value is 0.04. That's less than 0.05. We reject the null. So the probability we get a standard deviation of 0.085 or more is 0.04. At an alpha level of 0.05, we have sufficient evidence to suggest the standard deviation is greater than 0.05. Because essentially, even though we've never done one like this, because it's not part of the AP curriculum, essentially the standard, our claim is that the standard deviation equals 0.05, and HA is we're concerned if the standard deviation is greater than 0.05. And what we ended up with, well, here's the claim, 0.05. So we're centered on that. We're centered on the standard deviation. They tell us normally distributed. And we ended up with S of 0.085. And we found out that that happened 12 out of 300 times. So this area right here is 0.04. So that's what's going on. I hope that helped. This question right here, or this part of the question, part B, was worth 1 point. So we had 4 points or 3 points for the upper part and 1 point for the lower part. You get all 4 points. That's awesome. If you had 3 out of 4, that's 75%. You make 75% on AP exam. You have a 5. You only need a 72. All right. I hope that helped. And thank you for watching. Hope you'll stay tuned for the next one.